chatbot can do both for them, right? And the same is true for the code base, right? The models now are good enough to sort of understand a code base that's sort of medium size, right? And walk you through how it works. And then when it comes to fixing, same thing, right? If you provide a stack trace and a whole bunch of code, then obviously GenAI can sort of sometimes, for most of the time, guide you in the right direction, and perhaps even suggest some fixes. And we have another bot around sort of doing this continuously. So the technical debt bot, right? Again, there's something that humans don't really want to do, like maintaining accurate readmes or maintaining accurate whatever, right? So you can have a bot sort of just do this for you on a daily, weekly basis, and then generate PRs. All right, so those were the use cases, but we're here to talk about how to actually make them happen in production, right? So let's talk operations here. So you may have seen the curve on the left here is the Gartner hype cycle, right? So when a new technology comes along, people get very excited, and then they get very disappointed. And then the ones that don't get too disappointed sort of make it work, and then eventually it sort of plateaus, right, productivity-wise. And for AI, it's exactly the same thing, right? So I've sort of reshaped the curve a little bit to be slightly more realistic, right? With AI, the first peak is extremely high, right? People get really excited the first time they see a RAG chatbot or whatever, right? And then reality like hits pretty hard, right? And so what happens after that is, operation, right? Making it work, right? For real people on a daily basis. And I'm going to describe what it takes to get there. And so eventually you reach that new normal with AI where everybody uses it. And so that's sort of what we're calling here the boring AI, right? It just works. It's part of the workflow. People expect it to be there. It's useful, and people aren't really just sort of amazed by it anymore, right? So how do we get there? Well, there's a number of steps to get there, right? So it's very easy, again, to get blown away by a prototype. But before you get to true business impact at the bottom here, you have to go through all of these steps here. So internally at NetApp, by the way, we have a whole bunch of bright engineers who are going to build a whole bunch of prototypes, right? You may also buy sort of AI applications as well. And I'll describe in the next slide that even if you buy AI application, you still have to go through a whole bunch of those steps. So I'm going to go through each of them in 3 or 4 slides here, but in a nutshell, yeah, you got to worry about, obviously, source control. That's sort of, and all kinds of DevOps best practices, that's sort of obvious, right? Then you got to worry about where you're going to run this thing. You have to worry about whether or not it's secure or secure enough for your own guidelines internally. You have to make sure that your legal department isn't going to be too upset with you, right, depending on what you want to do. You have to make sure that you monitor the application, make sure it works all the time, because if it doesn't work, obviously, you don't get any value. You have to make sure it doesn't cost a whole lot, right? You got some sort of cost control involved. You have to understand who is spending what for what purpose and whether we're OK with that. And then when it does break, you need a team of people who understand the whole stack, right? Because with AI, if you have models in the cloud, well, you need somebody who understands sort of the network layout and then who to file a ticket against when things go wrong. Right? And then the hard part is once you've done all this and you have an application that works all the time, well, you need to get users to actually use it to get value. If they don't use your excellent application, you don't get any business value. And then you have to make sure that you get the value you were hoping to get. So you need a set of metrics that look at whether or not you're reaching your goals, right? And if you're not, then you got to iterate, right? You see put a loop back here. You sort of have to iterate between metrics and adoption for a while. That's the ramp up that was described on the curve earlier, right? And then eventually, once you've done all this, hopefully you get true business value. Right? So I'm going to go through a few. So first, yeah, next slide. Yeah, even if you, like I was saying, even if you do buy an application from a vendor, you still have to worry about security and compliance and monitoring and so on, right? All of it still applies. So let's dive in a little bit here in the next 3 slides. So if you start from a prototype, obviously it's going to have to be source control. That's sort of obvious, right? But not only that, but you're going to need sort of a very strong sort of test coverage right off the gate, right? You're going to need for those tests to run, so you can merge, you can gate all the merges, right? You need to have a very strong sort of CI/CD story. You need numbered versions so that everybody knows at any given time what runs where. And then something we've sort of learned more recently is automated upgrades are important. So it's easy in this container world that we're in to just build an image and then forget about it, right? But what we found out is that if you don't actually automate upgrades of your dependencies, well, once you want to make changes to that app and you haven't upgraded anything in a year, well, then it probably doesn't work anymore. So you're better off sort of upgrading as fast as possible, as soon as possible, so you identify issues right away. And then once you have something like that, that's the deployment phase. So at NetApp, we have two sorts of compute resources, a whole bunch of ephemeral ones that last, a number of weeks or something. But obviously, an AI application is going to have to run a year or 2 or 3 or maybe more, right, if it's very successful. So the way we do this is with Kubernetes. Kubernetes are great because it sort of isolate a whole bunch of concerns away from application developers and onto like the Kubernetes people, right? And we don't have to worry about, we don't have to maintain, we don't even have to know where it runs or any of that, right? The applications, people can do their thing, and then another set of people worry about the clusters and the health of everything else. And with Kubernetes, we also get sort of automated remediation at times, right? The images can move around based on things that are happening in particular nodes. And also allows for a rollback strategy when things do go wrong, how to go back to a better state, the previous known good state. And then, you're also going to need a staging environment, right? So a human can actually test before something goes into production. All that is probably obvious to all of you, but it's part of the journey to go from prototype to actual production application. Security-wise, same thing. There's a number of things to worry about here. In general, our security team wants to know who is using it, what they're doing, and then they're really interested in where the data goes, right? Because we don't want to be, in the news having like leaked all kinds of stuff to a third party. So we really want to understand where the data goes when it comes to AI stuff, right? So we control every data point. We have to understand if our stuff is going to be kept anywhere that we are not aware of. So we have to ask our vendors, okay, what happens here, what happens there, what happens, and so on, right? Until we understand, all right, this is where our data is going to be, and are we okay with that or not? Next one. And then same thing. So we have security requirements, and then we have sort of compliance requirements that are some of them legal requirements that you don't necessarily think about. We have a whole bunch of contract requirements with vendors. We also have, even if we're not going to pay for an application, we still have license requirements that we have to follow. And then usage limits, right? So I don't have to tell you that AI at times lives in sort of a gray area legal-wise, right? And so our legal team sort of tells us what we can do and what we cannot do. And so then we have to make sure that that's the case. That's what our users, not only our users are aware of it, but then they have no choice but to do that. Monitoring, all right, so we've got to monitor the nodes, the application, Slack alerts, and so on, right? That's sort of how we do it internally. Cost control, same thing here. So we are, as our AI our usage grows, our cost grows, but we still want to control that we don't spend our money too fast, right? So we have like soft thresholds, hard limits, and then we have like big panic buttons where we can just like quickly step, okay, you can't spend anymore until we talk to you for a bit. Next slide. All right, and then the support part is probably the one that takes the longest, because you sort of have to build a team to handle your application. Because an AI application is going to rely on a whole bunch of components, right? So I mentioned Kubernetes already, but they themselves rely on hardware, and then they rely on networking, right? And then we're going to rely on AI models in the cloud as well, right? So when something goes wrong, then somebody has to understand who to talk to and whose problem it is and so on. And if you've ever dealt with networking issues, sometimes it can be pretty complicated. And then once you've done that once, you better like sort of document what you've learned in a post-mortem. Otherwise, you keep redoing the same thing over and over and over. And then the last two, adoption. Again, let's say you've done all of this that I just said here, well, then you have to get users to actually use the application to get value, right? And humans are, they don't necessarily want to change their habits, right? So you you have to tell them, you have to do marketing, and you have to tell them, repeat the same thing a few times in a few different formats, by email, by videos, and so on, to get them to use the stuff, right? And then you have to sort of show them the features, and then you have to make onboarding very fast, right? Like our developers, or maybe any human, sort of limited patience on how to learn a new thing, right? So the easier it is, the better it is. And then the only way to get value is for them to actually get something useful out of your app, right? So you have to understand whether or not they are getting it. And if they're not getting it, why that is, right? So we sort of combine metrics so we understand what people are doing or not doing. Then we iterate between metrics and new features. We see a certain pattern or a certain lack of pattern, and then we integrate new features, and then we see if the adoption grows. All right, so I'm going to show you, or we're going to go through 2 examples of that process. And the first one is GitHub Copilot.
Yeah. So I'm going to go over the 9 examples or concepts that Jerome said on, specifically with GitHub. Can you go to the next slide? Yeah. So specifically, I'm going to cover that over some challenges that we have and how we use some of these ideas. So for instance, one of the challenges that we've had was getting access to Copilot. I'll also cover how we monitor costs, how we train users to actually use all the new AI features, and then how we actually track success. And so, you can keep it there further. So right now, what I have here is like our adoption, right? So this is what our adoption curve looks like for actual using Copilot. So it's about half of our engineering team use Copilot on a weekly basis, essentially, at this point. So how users get access. So one of the first issues we had very early on was users getting access actually to Copilot. So most of our on-prem tools, the way it works is you just log in and you have access. GitHub's a little different, right? GitHub is a service outside of NetApp. You have to have a different username and password. You have to get into the right IDP group so you can log in. And there's a bunch of little steps that, if you've never gone through that process before, is kind of painful to get logged in. So what we ended up doing here was we created a process where once a user created their GitHub user account, they'd go to a page that they just entered their NetApp username, and we walk them through each of the steps. Like, make sure your email address is there. We would check and then put on the little issue saying, hey, you don't have your email address. We added them to the right IDP groups. We gave them all the steps so that essentially anything that could be automated on the getting access to Copilot parts could be automated so that they got access significantly faster. So we went from having it was like 30 or 40 issues a week of people having issues getting access to about 2 or 3. And so it helped drive adoption as users could easily get access to the tool and start actually using it. Once users started getting access, we started looking at cost, right? So there's a bunch of different costs associated with Copilot. And the first one is just going to be licenses, right? Users sometimes will use the tool, sometimes will not. So we ended up creating an automated process just to check when users are using their licenses. And if they go 60 days without using a license, we just remove their license to save that cost. And so that was like the easy thing we did right away. The harder costs are when we get to things like premium models, right? So every model has a different cost in Copilot. And we have 2 sets of licenses. So we have business and enterprise. Business license lets users have 300 free premium requests. Enterprise lets them have 1,000. And so we would monitor when users would go over that and just switch them to the higher license to save cost on actually running the models. We also have a group of users who have decided, hey, my AI requests always need to use the most expensive model all the time. So we monitor that and email those users letting them know that, hey, Opus, while it's great, should not be used for every single AI request that you have. Training's another one that's really kind of hard. So if you just rewind 10 months ago to the beginning of the year, GitHub Copilot was just autocomplete when you type and ask mode. There was nothing else at that point with the Copilot. Today, you have a dozen different models you can pick from. You have MPC servers that you can set up. You have custom instructions. You have prompts. There's a ton of new features that have been added in just the last 10 months. And so keeping users up to date with that has been somewhat of a challenge. So we've broken that into like 3 groups. The easiest one is just your standard documentation. That's your Confluence or Wiki documentation where you just tell users, here's how you get it, and here's how the features work. What we started to do that we found was very useful was we created these monthly videos where we did like a deep dive on an actual, in this case, I have an example here of agent mode, but just how a specific feature worked, how they can use it, actual like showing them how it works, and then ideas of how they can use it in their own workflows. And then recently we started doing weekly office hours. So that's like a 30-minute period where people can just come in, ask questions, get help, and talk with other users who are having similar questions. And it's helped kind of get users to know some features that they weren't aware of. And then last is just getting, are we getting value out of this, right? One of the problems with getting a tool that is not in-house is you're 100% dependent on GitHub, in this case Microsoft, for metrics. And so they had very limited metrics to begin with. Right now, what we've ended up doing is they have 2 APIs. One API that just tells you, does the user use the tool or not? And the second one just saying how much like a team or an org use the tool. So like we can't, at the moment, get user level metrics. So we ended up creating teams for every manager and then syncing that with our IDP group into GitHub so that we could keep those teams up to date. And so we ended up creating dashboards for the various managers, every level up, so that they can see just as a high level, my team is creating this many lines of code with AI. GitHub has finally added user level metrics, so that was released last week. So if you're an enterprise admin, you'll now have a dashboard like this as of last week, where you can actually see user-specific metrics and download those. We're working right now internally to make dashboards for that so we can get more granular level. But these are like some of the challenges that we've had with Copilot.
All right, thanks, Chris.
Yeah.
All right, so the other application we're going to talk about is what we call the LLM proxy. So when you get started with AI, you realize that you have now a whole bunch of options in terms of where to get your models from, right? So your models might be in the cloud. Here I've put Azure and GCP, right? But you may also have, at the bottom here, models on-prem. So you realize that if you want to expose AI to your developers and you don't do anything else, so they're going to have to deal with a whole lot of different endpoints. They're going to have to deal with a whole lot of different authentication tokens and schemes. They're going to have to deal with even different API protocols between models, right? You don't talk to an OpenAI model the same way that you talk to a Gemini model, for example. And then on the admin side, you're going to have to deal with all kinds of different consoles and reporting mechanisms. So our solution to that, to help with, next slide, right? So to help with all the concern that we've described so far, right? Whether security, compliance, deployment, and so on. We've come up with this application we call the LLM proxy, and it's an API gateway, basically, right? And so it provides to our developers and our internal applications single URL. It helps us load balance across regions. It helps us sort of hide all the differences between clouds and on-prem models. It helps us track the costs and the activity, again, per user, per application. And then we can sort of set limits as well on how fast they can spend our money, right? And all that is built on an open source project called LLM, and we support them with a support contract, right? So we build this. It's actually 2 applications, right? It's both an API server that mediates every call between developers and models, and it's also a web application where we let them sort of get, first of all, tokens to even gain access, right? But then we also show them a whole bunch of metrics on how their application is doing and how much money they're spending, and then we sort of combine all the documentation in that web application as well. So one of the first things that we have to educate our users on are all the models, right? There are more models, honestly, every week, right? And it's pretty hard as a user to understand the differences between, let's say, 5 mini and 5 nano and 5 chat, and forget about all the Claudes and all the Gemini models, right? So what we try to do is we try to simplify the differences, and we show them this view in the LLM proxy web application. We show them a catalog of models organized by type here. You can see chat, embedding, re-rank, right? And we show them what the models can do. We show them how much it costs, the quotas that we get from the vendors. And then we try to sort of simplify the complexity by showing them like, those little dollar, I don't know if you can see here, dollar bills, the brains and whatnot. We should say, okay, well, we think it's that smart, and we think it's that fast, and we think it costs that much, right? And that's not enough, honestly, to pick a model, right? But developers will have to play around and see what works best for their use case, but that's where they start. And then again, we can then show them, once we get a token and we create an application, we can show them what is happening with their application. So we can show them here, I'm showing the cost per user for this particular users here, or a set of tokens. Right? So that's how we let users understand their cost and hopefully manage it, right? On top of all the other alerting that we have on our end, we sort of rely on users to keep an eye on it and make sure that they're not spending suddenly tens of thousands of dollars. The other thing we do in the LLM proxy is we show users what already exists. Because that's, when you have 2,000 right engineers, a whole bunch of them are going to have the same idea at the same time. And so one thing we got to do is we got to show them what already exists, so that, okay, we know that people are going to reinvent the wheel, but if it's just 2 instead of 10 people, that's better, right? So we show them a registry of registered application that go through this LLM proxy, and we say, this team, I don't know if you can, it's very tiny here, but we show them who owns, what application exists, who owns them, where is the code, where is the URL, and then we show them, and that's the 3 boxes at the end, and we show them how many users that application has. So it gives them an idea of how perhaps mature the application is, right? Or at least at the very minimum, how popular the application is. So that gives them a start, and you can say, oh, wow, yeah, I was going to build that. I can instead go talk to that team and understand, all right, can they actually handle my use case? If not, can I at least learn from them, right? So it's a way to sort of decentralize innovation at NetApp, right? The tools team isn't in charge of solving every problem. We also rely on teams to solve their own problems. On the admin side, since we now have this mediator of every call, we can now provide our admin with a single view. So here what I'm showing is all the errors for a week in October, right? End of October. You can see it's hundreds of errors that we're getting, right? And the errors are organized by type. Because a lot of the errors are user errors, right? So they sent too much content, or their token had expired, right? Or they're using a model that doesn't exist, and so on, right? So that let us, on the admin side, zero in on really what is urgent, right? Obviously, these errors we can ignore, right? But if suddenly a model starts misbehaving, that's where the fun starts. Because now we have to understand, all right, what's happening? Who's going to get the ticket? Are we going to have to contact Azure support or whatnot, right? Or is this something internally? Is the firewall misbehaving or whatnot, right? So we do that. We track all the errors. We track, again, the same way, all the cost. And then we control how fast people can spend money by setting concurrency limits. On top of, on the compliance side, we disable sort of features that our own legal team doesn't want us to use, or security team, right? So that's how we protect ourselves here. We only let developers use what, as a company, we've agreed they can use. And so this is supported by a group of people. It's really a team effort to do this. So an SRE team that answers the call, but then they contact other teams to get issues resolved. So it is still growing. The usage of AI internally is still growing. So I'm showing you here the number of tokens. That's in billion, right, per week. So we were at 2 billion a week in June. We were at 6 billion not too long ago, and then something is happening in October, November, and we'll see if that lasts, right? Since then, we're also adding, we've integrated an MCP gateway, right? If you know what MCP is. Very similarly, we sort of front MCP servers at NetApp for the same reasons. It allows us to, first of all, communicate what MCP servers are sort of quote unquote allowed or preferred, right? So people don't use random MCP servers. And then it also see who is doing what, where, and why, right? And then obviously we're adding more cloud models, and then more on-prem models. So the options there keep growing, and it's a good thing. It makes our life a little more complicated, but it's a good thing in general to have so much option. The other use case we want to talk about today is a knowledge chatbot. And that's because this is sort of prime example of how you go from a prototype to true business value, right? So a RAG chatbot is one of the easiest things to set up. You can do this in like 20 minutes, right? And you can create a great demo in like 2 hours, right? And maybe you've done this yourself. Maybe you've built one, right? It's very easy to sort of think that you've come up with a great way to solve answer a whole bunch of questions, right? You've ingested, let's say, a few PDFs, and then you have an index, and then, I can answer questions on the PDFs, right? But that's really just the start of a long journey. I would say you're about 10% there before you can even say that you've achieved something that's tangible, that has business value. So we have one of those. I'm going to call here the engineering knowledge chatbot. We feed thousands of pages of internal documentation, and then we let people ask questions on that documentation. But next slide, right? But immediately, once you put that in place, immediately you have pretty important challenges. So the first one for us, again, we have about 2,000 engineers, and the list of tools that they use is pretty wide, right? And so the first step for us is, okay, what tools are people going to ask questions about? First of all, where is the documentation for that tool? And who owns the documentation for that tool? Right? In a large company, sometimes it's not obvious. You sort of have to dig, right? And then you have to document who it is and who owns what, right? And what's great about a chatbot to do this, right, compared to a search engine, is that you get the actual questions that people were asking for, right? So you know exactly what they wanted to know, and you know exactly what answers they got, right? So you get suddenly great visibility on whether your documentation is any good. And guess what? It probably isn't any good, right? And so if you track that, then now you can start improving documentation over time. But to do that, well, somebody's going to have to figure out why the answers are bad, right? It might be the chatbot itself, right? Maybe your chunking strategy is whatever, right? You're screwing up all the tables, perhaps. I don't know, right? But somebody has to go through all the bad answers and then, classify them, right? Is this a chatbot problem? Is this a user problem? Did they ask, like, is the sky blue? And obviously the chatbot isn't, whatever, right? Or is this a documentation problem in the people who own the documentation are going to have to do something? Next one. And then on top of that, at NetApp, not everybody has access to everything, right? Some of that stuff is compartmentalized. So if you're going to create a chatbot and ingest content, well, you have to also follow the same permissions as the source of knowledge that you indexed, right? And you can't really avoid that. But that's part of the complexity. Maybe you didn't think about that when you created a prototype, but you're going to have to do it, right, before you can put it in production. And then you do all that, and then you realize, oh, shoot, okay, well, the content keeps changing. So now I have to reindex on a daily basis, right? So you need another piece of software that does that just keeps the content up to date. And then once again, let's say you do all this and you're very sort of proud of it. Now you have to get people to use it. Right? So again, if you have 2,000 engineers, you're not going to get them to try a new URL tomorrow. It's just not going to happen. It will take weeks, months before all of them try it, right? So how do you sort of speed up adoption and truly get faster answers to the people who need them, who might not know that your tool exists? So next slide. So what we've realized is that a RAG chatbot is really, it's not one service, it's 4 services, right? So it's the chatbot itself, the UI, right, where users enter the questions and the answers. But it's also a completely different application for content owners, right? So it's the people who actually own the tools and own the content. We have to show them what questions their users are asking, what answers they're getting, and whether or not they're happy with it, right? So we let users sort of provide thumbs up and down, right? And then we need those SMEs, those subject matter experts, to then help us understand where the bad answer comes from, right? So they're going to have to do some triaging and say, oh, yeah, it's my fault, or no, it's not my fault. It was documented here, but the chatbot didn't work. Right? The third piece of that, okay, is the constant index refresh, right? That's not too complicated. And then the fourth one is around adoption, right? That UI, that new URL you created, good luck getting 2,000 people to try it. But if instead it can be your chatbot can be a REST API, well, then you can integrate that with other workflows that your developers are going through, right? And maybe you get adoption a lot faster that way. And we've done that. We've integrated actually this particular chatbot in another chatbot that had way more users. And then people don't even have to know about the other UI, right? It just works. So what we've realized through that exercise, it's not very surprising, is that RAG chatbot are garbage in, garbage out. And by and large, the main bottleneck to good answers is good and relevant documentation. And it's, for the technical team, perhaps a little disappointing because it's no longer a technical problem. It becomes a management problem, right? So now you have to make sure that your teams have the time to prioritize solving documentation problems. And it's your only way out of that problem, right? If you don't show them what's not working in the doc, it doesn't get better, and the documentation will stay poor forever. All right, so that is almost the end of our talk. So I'm going to leave you with three sort of main takeaways here. One is, AI is not boring at all. AI is exciting, more exciting every week, frankly. But making AI boring means making it reliable, impactful, indispensable, right? Rather than this amazing thing that is going to solve world hunger, right? And frankly, it's a journey and not a destination. We're not done. AI adoption is still growing internally, and I expect it to keep growing as tools get better. Perfect, and we have a few minutes for questions if you have any. Yes?
How much time do you think you estimate engineers are spending as they're adopting the AI tooling, spending, working on internal AI tooling information, feeding it, writing documents, configuring their internal workflows and whatnot versus the output?
Do you mind repeating that with the microphone? Or?
Yeah, so
Perfect.
how much time do you think the engineers are spending on not using the AI, but configuring the AI for their individual expertise areas, feeding it documentation, configuring stuff internally versus getting to use it?
Oh, yeah. Well, I would say we have two types of users. We have early adopters who are willingly going to do all the legwork to be the first one to use something cool, right? And then we have users who don't want to spend any time doing any of that. And it's just going to have to work within the confine of what they're already using, right? So in general, we try to minimize the setup time because that's the barrier to adoption, right? Okay, so thanks. Ideally, the answer to your question is 0. It should just work, right? That's how you get the best adoption. In reality, yes, there is a little bit of setup involved.
Hi. Do you still require all the changes generated by AI to be reviewed by people, or how does that work?
Software changes?
Yeah.
Oh, yeah, for sure. Yeah. Yes, that is yeah.
So isn't that becoming like an obvious bottleneck?
It is, yeah, it is. So we have an application that generates unit tests, for example. And so our ability to get those reviewed is lower than our ability to generate the unit test in the first place. So we're definitely bottlenecked by human review right now. And that's because, yeah, we don't trust AI to just blindly sort of do stuff just yet. And that's true for code, that's true for MCP tooling as well, right? So some tooling will require humans to say, yes, I really want you to create a new page or do that. It's still a very critical part of AI interaction today. You can only trust AI so far or so much, right?
And maybe you can mention some limitations you guys run into, like developers complaining on I don't know, for example, it's really good for tests, or like, I don't know, some new features that are well documented, but maybe it struggles with some, I don't know, bug fixes in some complex code?
Yeah.
Or
Yeah, definitely. And I think teams are learning sort of every day what they can get out of what tool and what model, right? Yeah, it's not perfect yet, but it's getting, so it was so much better, it's so much better today than it was 2 years ago.
And what about limitations of models themselves? For example, what we find is that, let's say with Cloud Code, the models with the 200K context is really limiting, especially if you add some MCP tools. That's you can just cut this in half, and basically now you cannot really work with large code bases. It has a limit of like 25,000 tokens per file that it can load and stuff like that.
That's true, it's true, but I don't know if you heard the concept of overturned window, right? The discussions we have today, we were not having them 2 years ago. Like, it's amazing how far, right, the progress has been. So yes, it's not, there's a whole bunch of limitations still, but it's way better than it used to be. You still have to understand what it can and cannot do. That's unavoidable right now, right? But all the reasons that you mentioned, right? Limited context. And even within the full context, right, we know that models don't necessarily are sort of blind to some of it, right? They can see like sort of the start and the end better, and they can see what's in the middle. Yeah, so there is a learning curve to all that. But frankly, if you use, let's say, Cursor or one of those agentic AI tools, it's pretty, I don't know, I'm still amazed by it. Can be done, right? Even if it can't do all of it for me.
Do you guys have maybe like some best practices that you were able to develop internally? For example, I know Opus or Gemini is best used for planning, but Sonnet is best used for coding or stuff like that.
So yeah, so on the GitHub side, we prefer Sonnet. So like we let developers choose what they want. So we kind of said Sonnet tends to be better. We had a huge, like the moment we added Sonnet, people switch and have stuck to it. So before we allowed models, we were stuck like on the GitHub side with, I think it's GPT-4, one is what's the base for Copilot. Once we turned on Sonnet and told people that was a little bit better, a lot of people tried it out and then just switched. So like, I think it's 70% of all our code generation today is on Sonnet 4 or 4.5, because developers switched and it was significantly better. I think as more models come out, we'll continue to switch as, either it gets bigger contexts so it can do more with large code bases, or, faster, right? Like some of these models are slow, like Opus can be very slow. But yeah, so we do switch, like we did see a very quick switch to from GPT-4 to Sonnet 4 when we enabled it as developers started using it.
And the last one, I promise. But for specific tasks, for example, so like for coding, Sonnet is best, but for example, we really like Codex for like reviews. We find that Codex actually gives better results reviewing the code, right? Not really writing the code, but do you guys distinguish do you have like best practices what to use for which specific task?
So we didn't talk about really the tool that does code review a whole lot, but we do see that quite a lot. So we track sort of acceptance rates of review comments, and we saw sometimes we've now twice reversed a change in models, right? We'll switch that particular tool to a new model, and then we see the acceptance rates sort of drop, and then we just go back to like another model. So you're correct. There are definitely models that are better at certain tasks. It's just that models don't come with like a manual, right? It's sort of stuff that you have to find out on your own.
And like every month, there's a new version or a new model, so it's changing very quickly as well.
Okay, I lied. One more.
One more.
So,
okay.
And for example, for review especially, do you guys try to use like multiple models in like sense that the more the better, or it was too many false positives? And
we try to find the best ones out of all the ones that we have access to. It's really how we go about it. Right? We don't let, for that particular tool, we don't let users really pick. We just have instead internal metrics to help us decide which one provides the best results. And all of that is prompt, prompt dependent. Your prompt might not work with this model, might work better with this model on top of what the models themselves are able to do. So it's a sort of complicated dance there to find the sweet spot. What prompt will work with what model to give you the best results. And so you do need a DevOps strategy there. Right? You need the ability to, and metrics. You have the ability to track what the actual results are, not just sort of send bottles to the ocean and hope that somebody finds them. That's the whole talk.
Okay. Thank you very much.
Yeah.
I think all your questions were great. Very interesting. Thank you. So I have a question. So I see what my company's doing in this area. I see what you guys are doing. I feel like any company your size is pretty much going about this the same way and relying on the external infrastructure. Now, obviously, I'm in your building, I'm drinking your coffee, so you guys are clearly the best on the planet at this. But let's hypothetically say that there was a company out there called NetFoo, and they're your competitor, right? And obviously they're inferior, but you guys are the best. But there's NetFoo out there, and they're competing against you. And you guys come out with feature Gorp, right? And you've got this whole AI infrastructure spread out across the cloud that has helped you build Gorp. And the NetFoo people jealously, with their evil hearts, look at you and say, oh my gosh, we got to meet them in the market. And so they go to their infrastructure, and they tell their infrastructure, our prompt is, give me NetApp foo. And then 2 months later, thanks to the fact that you guys have shared your cloud AI infrastructure across the planet, the AI spits out your implementation in their context. So
So that's part of the, when I talked about compliance requirements and contract requirements, that is very specifically what our legal teams and security teams protect us against, right, is this exact scenario. We make sure that none of our IP leaks outside NetApp, right?
Well, I don't know about your security people and your legal people, but when I talk to them, it's very clear to me they don't understand what I'm doing.
Well, there's two levels of security, right? There's security features, and then there's contract requirements. Right? So you sort of use both to get some trust that people that you're giving your money to are going to handle the data the way they said they were going to handle your data. That's part of the risk in here, right? You have to trust cloud vendors that they are going to follow the contract you have with them and not lose your data or give it to somebody else, right?
And how confident are you that the protections are keeping up with the level of innovation?
I think that, that's up to our procurement people, legal people, and as a company, we decide which vendor we're comfortable trusting and not trusting.
So hypothetically, the NetFoo Gorp scenario is a real-world threat.
It's a real-world what?
It's a real-world threat.
Yeah, if you're gonna use a certain number of AI tools out there, they keep your data, right? You send them, and then they keep it, and sometimes they even train models where's your data. So then you lose your intellectual property that way, right? So yeah, we don't do that, right? We rely on contracts and features to make sure that that particular scenario does not happen.
Thank you.
Hey, in one of your previous usage graphs that displayed the number of tokens generated, you guys went from 6 billion tokens generated per week or something to 16. What are you guys doing over there?
What are we doing? So those were not generated tokens, so it's total tokens, right? So it's both, it's the sum of what we send and what we receive, right? So I suspect that somebody is creating a big index of something internally, that's my guess.
Then we also turned on the MPC gateway at that time, so it could be a little bit of that as well.
Yeah. So I think this all happened within the month of October.
Yeah. But we know that usage is increasing. People are finding more and more use cases, right? And since we've decentralized innovation, we have some visibility via the registry that I showed, right? But sometimes we don't necessarily always know for a while what people are doing internally, right?
And like on the GitHub side, like since we track how many requests a user made, if I just go back 2 months ago, I think I had like 4 users who went over 1,000 requests. This month, I'm over, I think it's like 150 that have made over 1,000 requests. So like the number of people using AI is using AI, and the amount they're using AI internally is going up exponentially as well.
All right. No, one more.
So I tend to ask this question at the end every time I'm at a talk where someone's presenting about AI. So don't take this the wrong way. How addicted is maybe the wrong word, but like if tomorrow the AI went away or was broken or unavailable, like as your AI adoption has increased, like how much risk have you potentially exposed yourself to development flows, internal workflows, CI integration, like all that sort of stuff? If the AI infrastructure disappeared, like how linked are you now to that being there? Like if it went away tomorrow, how much of your developer workflows, how much of your developer productivity would go away?
Yeah, it wouldn't be good, right? It wouldn't be good. That's just reality, right? It's so useful that it's getting sprinkled everywhere. Yeah, it's a risk, but it's also an opportunity, right? It helps us go faster in a number of ways.
Okay, I'm asking like, okay, great. So it has a hiccup because it's an external thing. And I'm asking from a position of I also deal with this at work. So it goes away temporarily. Mm-hmm. Does that mean all of the workflows inside the company that use it break?
Not all of them. Yeah, no.
Okay.
Not all of them. Yeah. It's not like we would just go home and chill for a bit. Yeah, people can still do work. It's just, some areas are going to be.
Okay, so it's not integrated so tightly right now that like it can't go away.
That's correct.
Ever.
Yeah.
Okay.
Yeah. It's just a lot of people will get very mad. Yes.
Yes.
All right. No, one more.
So in terms of adoption, AI tools, obviously there's like the really easy, I'm going to do a chat, I'm going to do some completion while I'm typing into a file. Maybe you start using agents, maybe you go all the way, start doing MCP. Do you see adoption following a trend you would expect with the complexity of the AI tooling?
The trend that we would expect?
Yeah.
Yeah, so in general, I would say it's obvious during hackathons, for example, right? The hackathons follow very well the trends, the overall AI trends, right? So when MCP came out, you may recall that our hackathon, the latest one, had a whole bunch of MCP projects in it, right? So I would say that our developers do pay attention to what's happening in AI. They are trying to learn the latest thing. In that sense, yes, absolutely.
Any last questions?
All right, thank you.
Thanks, guys.